Now let us look at the compactors, the rollers, very important, other important machineries in the road construction. There are different types of forces that are applied on mat, the layer, or depending upon the type of force that we put on the layer, the compactors, the forces are classified into static, impact, vibratory forces. In these two, these static forces are the lower forces, vibratory and impact forces are larger forces, higher forces. Why compaction? Basically it is required? It is to improve the mechanical stability of the layer. It improves the resistance to the deformation. It reduces the moisture penetration. It increases the fatigue resistance. It even reduces the low temperature cracking potential of a bituminous layer. These are the types of rollers used in the road construction. This is soil compactor. This is asphalt compactor. This is a pneumatic compactor. So how do we say it is a soil compactor? There's a one steel drum and two pneumatic wheels on the back side. So this is used for compacting the soil, the granular layers. And look at this roller. We have two steel drums here, both steel drums, front and back. And generally this type of roller is called tandem roller or double drum roller, generally used for compacting the asphalt or bituminous layers. And you can see here pneumatic wheels, both front and back. Of course, back cannot see. So this type of roller is called pneumatic rollers. Except these pneumatic rollers, both these two rollers can be operated both on static mode as well as vibratory mode. So that means they are also they can be used as a static roller, they can be used as a vibratory roller. If you look at the types of rollers, we have static rollers, and then we have kneading compactors, and then we have vibratory compactor. A pneumatic roller is a kneading compactor. So if you take the static compactor or the static roller, the 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 compaction the roller achieves depends on the dead weight of the roller or the gross weight of the roller, and the speed of the rolling operation and thickness of the mat or the layer. Then comes kneading roller. You can see wheels here also. You can see the gap here. So these gaps, and this gap is filled by these wheels. So here, this, as I said, this cannot be used as a vibratory roller. The compaction depends on the gross weight of this roller. Of course, we can ballast this pneumatic roller. We can put sand or jelly or steel plates so that the weight of the roller is increased, and the compaction also increased. You can see the schematic diagram of the placement of the wheels, front wheels and the rear wheels. As I said, this gap is filled by this wheel so that we get continuous compaction. The overlap happens here. So as I said, the compaction of the pneumatic roller depends on what is the load of the gross weight of this pneumatic roller, and also depends on what is the pressure of these wheels. So the main advantage of using this pneumatic roller is it seals the layer, especially the bituminous layers. We don't want more infiltration of water. Theoretically speaking, we don't want infiltration, but we cannot avoid that. When pneumatic roller is used, it seals the voids, and also it simulates the field conditions. We get smooth surface. And the other advantage of this pneumatic roller is that it touches the spots which are not touched by the steel drum, because it's a kneading roller. The That's why it is called kneading compactor. Why? This is an articulated axle. The pneumatic roller is, the axles are articulated, means what? It touches all parts as can be seen in this figure. So that means the surfaces which are not touched by the steel drum, this pneumatic roller touches, and it gives good smooth surface and simulates the field condition. The other example of kneading compaction is this pad foot rollers. You can see these are called pads. This kind of rolling is operated on soft soils. For the same roller what we have seen earlier, the rollers, this kind of rollers, that attachment is made for this that pad foot attachment is done. So we do not get exclusive pad foot roller. It's a pad foot attachment as and when required, or whenever we are compacting plastic material, especially block cotton soils. So as I said, if all these modern rollers, they can be operated in the static mode as well as the vibratory mode. The compaction efficiency or the compaction depends on so many parameters. Number one, load. More is the load of this gross weight of the roller, more is the compaction. And it depends on amplitude. What is this amplitude? When vibration is switched on, the drum rises above from the surface, and the gap between the surface and the drum, when vibration is given, it's called amplitude. And frequency, number of hits per minute, vibrations per minute, is frequency. And of course compaction also depends on speed of the roller and thickness of the layer. So this is how you can see here the amplitude. So this is the surface, and when you switch on the vibrations, the drum rises from the surface so much, and this is the amplitude. The vertical distance of the drum caused by the motion of the eccentric weight inside the drum is called amplitude. Generally it's about 1 mm. 1 mm. So more is the amplitude, more deeper the layer get compacted. And then comes frequency. Said the number of such hits per minute when drum rises above the ground and then it hits back the surface. Such hits per unit time per minute is called frequency. Frequency denoted by hertz. So the number of cycles of the rotating device, that eccentric wave, measured in vibrations per minute, that is VPM, expressed as hertz, is called frequency. This frequency also impacts the compaction efficiency. So the frequency is the number of drum impacts of this eccentric mass per second or per minute. It is said that each material has got natural resonance frequency. If the material is compacted at its natural frequency, we get the highest density. So literature says these are the natural frequencies, resonance frequencies of the different types of material. Graded sand frequencies 1980 VPM, vibrations are 33 hertz, and similarly for a clay it is 1200 vibrations per minute and 20 hertz. So when material is compacted at its natural frequency, the material gets highest density, layer gets highest density. So this is the how the vibrations can be varied. You find a lever here. This is the lever. Then you can push this direction or backward, so that depending upon your requirement, whether machine can be put on maximum vibration or lower vibration. Generally for soils we use high vibrations. For asphalt layers we use less vibrations. That means whenever we are compacting asphalt layer or a bituminous layers, frequency will be high, amplitude will be less. Or whenever we are compacting soil or aggregate layers, frequency will be less, amplitude will be more. So what we have to observe, we are winding up the discussions on the plants and equipments. To summarize, see, for example, crusher, another one important observation you have to make. Crusher, let's say, the normal capacity is 200 tons per hour. A pug mill, generally 100 to 200 tons per hour. HMP, again 200 tons per hour. A paver can handle, paver capacity is 500 to 600 tons per hour. Similarly, the compactors, rollers capacity is 500 to 600 tons per hour. But what is observed by the studies, some of the studies that we have taken, the utilization of this equipment is not crossing even 50%. That means, if you recall what I said, the cost component of this plants and machineries in road project is about 15 to 20%. And the cheapest equipment that we get is roller, which costs about 20 lakhs. And if you look at the utilization, it's about not even 50%, less than 50%. So definitely this is an important observation that we have to make. So we should look how to optimally utilize these equipments during road construction. So it needs a lot of planning, construction planning. And yes, there are some concerns when we are talking about plants and equipments. We need skilled operators. Definitely industry is, we do not get skilled operators. Their retention is also less. Whenever they get better opportunity, they leave this industry and they go back. So this is definitely a concern. We should all look how we should overcome this deficiency, and a lot of training is also required for the operators, because operating these plants and equipments need different skill, higher skill, and the entire quality of the products that we produce, the layers, depends upon the operator's skill. So training of operators is also a very important requirement, again a concern. And all the manufacturers of these equipments, the dealers, generally they train the operators as and when required by the customers. So you can refer these references for additional knowledge. You can also go to the equipment manufacturers websites for information.